Hi, I'm Sophia Jensen, and this is my final project for CS3550. For this project, I created a database for a learning management system, or LMS. The goal of the database is to handle the main parts of an LMS, including students, instructors, programs, courses, sections, enrollments, assignments, and grades. Throughout the 5 phases of the project, I went from analyzing the requirements and designing the database to actually building it, and then adding some queries and advanced components like stored procedures, functions, triggers, and indexes. I'll start with the design from phases 1 and 2, and then move into the actual database and demonstrate how everything works. For phase 1, I started with the requirements analysis for the LMS. The system needs to support students enrolling in sections, viewing assignments and announcements, and tracking their grades. Instructors need to manage their sections, create course content, and record grades, while administrators need to manage the overall system. From those requirements, I identified my main entities, including user, student, instructor, program, course, section, enrollment, assignment, grade, announcement, quiz, and discussion. I also identified the business rules and relationships here. For example, a student can enroll in many sections, a course can have multiple sections, and an instructor can teach multiple sections. I also identified participation constraints, including which relationships are required and which can be optional. For example, an enrollment has to be connected to both a student and a section, while a course can exist without currently having a section. I also modeled user as a supertype with student and instructor as subtypes. This separates the general account information from the information that's specific to each type of user. This is the ERD I created from those requirements. Here you can see those entities and relationships visually. One of the main relationships is between student and section, which is a many-to-many, so enrollment is used to connect the two. You can also see the one-to-many relationships between things like program and student, course and section, and instructor and section. Each entity also shows the attributes and the primary and foreign keys that connect the design together. For phase 2, I took the logical design from phase 1 and turned it into a physical database design. I decided to use integer surrogate keys for the main tables, so each record has its own ID, rather than using something like a name or email as its primary key. Enrollment remains the junction table between student and section to resolve that many-to-many relationship. I also designed the database to be in a third normal form to reduce redundancy. Values that can be calculated, like enrollment count, available seats, and final course grade, aren't stored directly and can be instead derived from the existing data. This is the physical design. Here, I added the actual data types and constraints that I would use when implementing the database. You can see the primary and foreign keys along with things like character lengths, integers, and date fields. I also added constraints to protect the data. For example, role can only be student, instructor, or admin, semester is limited to spring, summer, or fall, and I have other check, unique, and not null constraints throughout the design. At this point, I had the tables, columns, keys, data types, and constraints defined, so the database was ready to actually be implemented in the SQL Server. Phase 3 is where I took the physical design from phase 2 and actually implemented it in the SQL Server. The script creates the LMS database, creates all of the tables, and sets up the primary keys, foreign keys, and constraints that I planned out in the previous phases. At the top, I first create the LMS database, and then I create each of the individual tables. These tables follow the physical design from phase 2, so this is where the data types, keys, and constraints actually get implemented. For example, the foreign keys are what enforce the relationships between tables, like connecting a section to its course and instructor, or connecting an enrollment to a student and section. I also implemented the constraints here to make sure the data being entered follows the rules of the database. Once the database structure was created, I added sample data so I could actually test everything. This includes the required 3 instructors, 10 students, 3 courses, 5 sections, and 6 enrollments, along with additional data needed for other parts of the LMS. Since the tables are related through foreign keys, the data also has to be inserted in an order that respects those relationships. For example, a student or section has to exist before I can create an enrollment connecting them. And then the last part of phase 3 is verifying that everything was created and inserted successfully. I have select statements for each table, which let me see the records that are currently stored in the database. Phase 4 is where I started using the data from the database to answer more specific questions. For this phase, I created one database view and 10 different SQL queries. The queries use things like joins, filtering, calculations, grouping, and aggregate functions to pull useful information from the LMS. First, I created a view for student course enrollments. This brings together information that's stored across several related tables, so I can see things like the student course section, instructor, and enrollment information all together. The main benefit of the view is that I can reuse this information without having to rewrite all of those joins every time I need it. So looking at the results, we can see that whole view. Query 1 finds all of the classes that a specific student has ever enrolled in. It returns their course and section information, the instructor, when they enrolled, and their enrollment status. Here I can see the enrollment history for this student that was selected. Query 2 is similar, but this one only shows the classes where the student is currently enrolled. This would be useful for something like displaying a student's current course schedule. Query 3 shows the assignments and grades for a student in a specific class. Along with the points earned, it calculates the student's percentage based on the points they earned compared to the total points possible. So this gives a more complete look at how the student is doing on each assignment. Query 4 creates a roster for a specific section. It returns all of the students who are currently enrolled in that section. So this is something an instructor could use to view their class roster. Query 5 finds students who are taking at least one course from a specific instructor. I use distinct here so that if a student is taking more than one class from that instructor, they only appear once in the results. Query 6 calculates the average score for each assignment in a specific class. It gives both the average points earned and the average percentage, so an instructor could use this to get an idea of how the class performed on each assignment. Query 7 finds assignments that are due within the next 7 days for a specific student. This could be used for something like an upcoming assignment or to-do list in the LMS. There aren't currently any records that meet that condition in my sample data, but we can see the query still executed successfully. Query 8 finds the top 5 students based on their average grades and their current courses. This uses the grade information, groups it by student, calculates their averages, and then sorts the results from highest to lowest. Query 9 counts the number of students enrolled in each section. It then sorts the sections from highest enrollment to lowest. This could be useful for comparing class sizes. And finally, Query 10 identifies students who are currently failing a course. It calculates their grade based on the points they've earned compared to the total points possible, and then returns students whose score is below 70%. Here we can see phase 5, where I added some of those more advanced database components. For this phase, I created 3 stored procedures, 2 functions, triggers, and 2 non-clustered indexes. These are useful because they let me reuse common database operations, automate calculations, and improve the performance of certain searches. My first stored procedure is called instructor weekly to do. It takes an instructor ID as a parameter and finds assignments in that instructor's sections that are due within the next 7 days. It returns the assignment name, course section, and due date, so this could be used to create a weekly to-do list for an instructor. Here, I'm passing in instructor ID 1, and these are the upcoming assignments that match that instructor. My second stored procedure creates a student's course schedule. This one takes a student ID and uses the enrollment, section, course, and instructor tables to return the student's courses, section numbers, instructors, and enrollment statuses. So instead of rewriting all of those joins every time I need a student schedule, I can just call the procedure and pass in the student ID. Here's the schedule that gets returned for student ID 1. My third stored procedure creates a course roster. It takes the section ID and returns the students in that section along with their student IDs and enrollment dates. I also sort the results alphabetically by the students' names, so this could be used by an instructor to quickly pull up their class roster. And here's the roster for section 1. Next, I created 2 scalar functions. The first one counts how many students in a specific section have missed 2 or more assignments. I pass in a section ID, and the function looks at the grade records for that section. In this case, a missed assignment is represented by 0 points earned. It groups those records by student and counts the students who have at least 2 missing assignments. Since this is a scalar function, it returns 1 value. So for section 1, we can see there are no students that currently meet that condition. My second function calculates the average grade for a section. I give it the section ID, and it finds the grade records connected to enrollments in that section and calculates the average points earned. This is also a scalar function, so it returns a single average value for that section. This is the average returned for section 1. For the trigger portion, I added a final score field to grades and created tables for quiz and exam scores so that I could calculate a weighted final score. The final score uses 40% assignments, 20% quizzes, and 40% exams. I created 3 related triggers, one for assignment grades, one for quiz scores, and one for exam scores. Each one runs after a score is inserted or updated and then automatically recalculates the final score for the affected student. The main benefit of triggers is so that I don't have to manually update the final score every time one of the individual scores change. So to demonstrate that, we'll first show the current quiz score, which is an 85, and the final score for enrollment 1. And then we will update the quiz score to a 95. And then we'll check that score again, and we will see that the final score has been updated as well. Finally, I created 2 non-clustered indexes. The first index is on student ID in the enrollments table. Student ID is used frequently when looking up a student's enrollment information, so indexing that column can help SQL Server find those records more efficiently. This is an example of the type of query that can benefit from an index. The second is on due date in the assignments table. Due dates are something that are searched frequently, especially when looking for assignments that are coming up or within a certain time period. So this index is meant to improve those date-based searches as the database grows. That completes this project. I started with the requirements and logical design, turned that into a physical database design, and then implemented and populated the database in SQL Server. From there, I created the view and queries for retrieving useful information, and then added stored procedures, function triggers, and indexes to make the database more reusable, automated, and efficient.